Hello and welcome to today's lecture on high speed local area networks. In the last lecture, we have discussed the legacy LANs which have served the purpose for many years, but unfortunately with the need increasing because of the application pull and technology push, there has been need for high speed local area networks, which is the topic of today's discussion. Here is the outline of this lecture: high speed LAN categories. Then high speed LANs can be implemented based on token ring. Essentially, it can be considered as extension of token ring, which is known as FDDI. Then the high speed LANs which are based on successors of Ethernet. We shall discuss in detail two technologies, fast Ethernet and gigabit Ethernet, and another alternative which is based on switching technology that has also led to high speed local area networks. And on completion, the students will be able to explain different categories of high speed LANs, distinguish FDDI from IEEE 802.5 token ring LAN. So, although FDDI is based on token ring LAN, but there are many differences which we shall discuss. Then explain how FDDI provides higher reliability compared to IEEE 802.5, and then we shall distinguish between switch. They will be able to explain or distinguish between switched versus shared LAN. They will be also able to explain the key features of fast Ethernet, and also they will be able to explain the key features of gigabit Ethernet. So, as I mentioned, the LAN technologies of 70s, those IEEE 802 committees LANs, the 802.3, 802.4 and 802.5, they can be considered as fast generation local area networks. As you have seen, their speed were varying from were in the range of 10 to 16 megabits per second. But availability of powerful computers, this is your technology push you can say, and emergence of new applications have created an urgent need for high speed LAN. And not only there is application pull, there is also technology push. As I mentioned, because of the advancement of VLSI technology, it is now possible to develop circuits which can operate at a very high speed. So, because of these two reasons, now it is possible to have high speed local area networks. As I mentioned, in this lecture I shall consider essentially three different categories of LAN. One is successor of token ring, which is essentially FDDI. Second is successor of Ethernet, which is one of the most popular LAN technologies, then based on switching technology. So, these are the things which we shall discuss in this lecture. First, let us focus on the FDDI, which stands for Fiber Distributed Data Interface. It is based on token ring, and this is supported by ANSI ISO LAN standard. As you can see, there is a close relationship between ISO layers, 5 layers, and the FDDI layers. As you can see, the physical layer is divided into two parts. First, two sub layers. One is physical layer, medium dependent. That means as we shall see, there are several mediums which can be used in FDDI: optical fiber, then twisted pair, and so that there is a need for separate physical layer which is medium dependent. So, PMD layer, sub layer we call it. Then which decides the transmission parameters, connectors, cabling. So, this is the function of this sub layer. Then there is another sub layer which is part of the physical layer, that performs encoding, decoding, clocking, then symbol set that is being used. So, this is done by the physical layer. And also there is a station management which encompasses both physical layer as well as data link layer, which performs ring monitoring, ring management, connection management, and also which performs that station management frames are generated by this particular sublayer. And as you know that medium access control performs the addressing, frame construction, token handling as you have discussed in the context of 802.5. And then the upper layers have been kept same, that is logical link control, which is part of the data link layer. This sublayer, as you know, acts as an interface with the higher layers of OSI layers, that is network layer and other layers. So, 802.2 LLC, which is identical to that 802.3, 802.4 or 802.5, same. Now, let us have a look at the key features of FDDI. One of the important features is the data rate. As you can see, the data rate has been increased from say 16 megabits 4 or 16, which was used in case of 802.5, that is token ring, has been enhanced to 100 megabits per second. So, it is almost a order of magnitude enhancement in speed, and it can support a maximum length of 2 km between stations using multimode fiber and 20 km using single mode fiber. So, we have seen that in case of token ring that network span was very small, and here the network span can be very large because of the longer lengths of the cables. So, and it can support as many as 500 stations, and network span can be as big as 200 km. So, we see that it cannot be considered just a local area network. So, it encompasses a much larger area. So, we may consider it as some kind of metropolitan area network. So, it can cover a very big campus. And some of the features of the physical layer are mentioned here. As I mentioned, there are two possible mediums which are supported. One is optical fiber. Here only the multimode fiber is shown here, but it is also possible to support single mode fiber for longer distance. Then the data rate in all the cases is 100 megabits per second, and signaling technique that is being used is different for the two cases. In case of optical fiber, it uses two levels of encoding, 4B by 5B, that is your that is one level of encoding, and emergent I, that is line encoding and block encoding. Both are being used here to generate data at the baud rate of 125 megabaud. I shall discuss about it in more details. On the other hand, in case of twisted pair, it generates MTL3 encoding, and maximum number of repeaters that can be used is 100 in both cases. And as I mentioned, when say multimode fiber is being used, distance that can be covered is 2 km, and for twisted pair category 5 unshielded twisted pair, it can be 100 meter. Now, as I mentioned, it uses 4-bit by 5-bit encoding, and we have already discussed about it. As we know that 5-bit code has no more than one leading 0 and no more than 2 trailing zeros. This is necessary for clock recovery purposes, and normally that it is line encoded by emergent 1. So, this block encoding and line encoding, these two are combined to have the encoding for FDDI. And this is the frame format. As you can see, there is a preamble which can be 8 bytes minimum, and it is followed by a start of frame delimiter, that is 1 byte, which specifies the start of the frame. Then there is frame control of 1 byte, which performs various control operations just like that 802.5. And then this is the destination address, and this is the source address. This is the source address and destination address, as you can see, can be either 2 byte or 6 byte, and data size can vary from 0 and it should be greater than 0. There is, as such, there is no limit, but there is some maximum limit. quite high. And then there is a frame check sequence. It is 4 byte cyclic redundancy code of 32 bit cyclic redundancy code is being used, and there is a ending delimiter of 1 byte, and frame status, as you have already discussed in the context of 802.5, is also used here. And the token that is being used here has got a preamble that is used for synchronization. There is a SFD, that's a start of frame delimiter, then frame control and frame status. So, this frame status is appended. So, as you can see, token is much smaller compared to the data frame, and it uses dual counter rotating ring for the purpose of reliability. In case of 802.5, we have seen there is only one ring that rotates in the anti-clockwise direction, in this direction. But here, as you can see, there are 2 rings. One is primary ring, another is secondary ring. So, the primary ring is normally in operation and secondary ring is essentially standby. So, so here, as you can see, the arrows are showing the direction. The primary ring has a direction in the anti-clockwise direction, and secondary ring has direction of clockwise direction. So, the packets or tokens can flow in these 2 directions. That means there are two ports, 2 and 2, 4 ports for each station, which has to be connected and to form a ring. Now, this dual counter rotating ring provides you higher reliability. For example, whenever there is a break in fiber, so some link has been disrupted, then automatically the ring will wrap off in this manner. So, these stations will be wrapped off, and that faulty part of the fiber will be bypassed. So, you see here, this is how automatically it supports fault tolerance. That means it detects where the breakage has taken place, and then it does the repair, and as you can see, now the ring is formed in this manner. So, bypassing the fiber, a ring is formed and it continues to operate, and it is transparent to the user. So, user will not know that this kind of failure has taken place. Similarly, if there is a station failure, that is also the defective station can be also wrapped up, and by wrapping up the those 2 separate rings, the secondary now becomes part of the active network, and as you can see, so a ring is formed in this manner, and these 3 stations can communicate with each other by using that token ring protocol, token passing protocol, and defective station is bypassed. So, you see, it has got built-in reliability with the help of this dual counter rotating ring. And although the MAC protocol is closely modeled around 802.5, but there is one difference. As we have seen in case of 802.5, a packet starts going and it goes around the ring, and usually the bit length, that means the time it takes to reach the transmitter, that length is smaller than the time, that the transmission time of a particular packet, and as a consequence, this particular station will receive the leading edge, and then after it will receive the leading edge, it will consume it, and then after the transmission of this frame is over, it will start a packet. That means always there is some data on the ring. That means after the transmission is over and this particular packet is removed, data packet is removed inside by the transmitter, then a token is introduced into the ring. So, this is how it happens in case of normal token ring. However, in case of FDDI, there is a possibility that this token, that transmission because of the very long length, the bit length can be longer than the transmission time. That possibility is there because the transmission rate is high, and also the length of each segment is very high. If you are using single mode fiber, it can be as long as 20 kilometer, we have seen that. So, it can be 20 kilometer. So, each of these segments. As a consequence, whenever there is a big ring, that bit length can be quite high. On the other hand, whenever you are transmitting at the rate of 100 megabits per second, the transmission time can be small, and as a consequence there is a possibility that the leading edge will not reach the transmitter before the transmission is over. So, you see in this particular case the transmission of a packet has started and it is already finished. Now, there is a possibility of introducing a token. So, immediately after sending a packet, a token can be introduced, which is known as early token release. And after this token is received by this station, it can start sending a data. So, you can see there is a possibility of having multiple frames in the ring simultaneously. That is what is being supported by FDDI. In FDDI there is early token release, that means immediately after the transmission of the frame a token is released, and as a consequence multiple frames can be simultaneously present in the ring. Now, the MAC protocol is based on it is a time token protocol, as you can see, to support both synchronous and asynchronous traffic. So, in case of 802.5, that is your token ring network, it is not a time token protocol. So, but using time token protocol, this FDDI supports both synchronous and asynchronous traffic. There are 3 timers. One is known as token rotation timer, TRT, another is token holding timer, THT, another is valid transmission timer. Now, these timers are used for the purpose of sending tokens and receiving packets. As you can see, a station waits for a token. After a token is received, it grabs a token, then it sets that that time rotation timer is set equal to that TTRT, that is essentially target token rotation time, which is usually set by the network manager and which is larger than the total bit length, that means the propagation time of the ring. So, it sets it, then it resets the time rotation timer, that token rotation, that time rotation timer. So, THT is set equal to this, then it keeps on sending until this THT becomes 0. So, the transmitter packets until THT is 0 and no packet is left. However, if there is no packet is sent, then the token is released. Now, as you can see, the time is decided in this way, that Dmax is the total propagation time of the ring, and Fmax is the maximum time of a frame, and this is the token transmission time, and this is the allotment of synchronous traffic. That means each station is allocated a fraction of time for transmitting synchronous traffic, and after transmitting synchronous traffic, if there is any time left, asynchronous traffic are sent, and all these parameters are added together, and which must be less than this TRTT, that is target token rotation time, and which is usually set by the network manager. So, by using this kind of time token protocol, the asynchronous and synchronous traffic is supported by FDDI. So, now we move to some other fast Ethernet, some other high speed LAN, which is essentially based on successors of Ethernet. So, as I mentioned, the successors of Ethernet uses 2 basic approaches. First approach is increase the data rate keeping the same shared approach. As we have seen, in case of 802.3, that is your Ethernet based on CSMS CD, the bus was used, a shared bus was being used for the transmission, or a hub was used, which is essentially acts as some kind of shared multi-port repeater, with the help of which data transfer was done. Now, using this shared approach, speed can be increased from say 10 megabits per second to 100 megabits per second, fast Ethernet, from fast Ethernet 100 megabits per second to gigabit Ethernet 1000 megabits per second, and nowadays 10 GB network is also on the horizon, that is 10 gigabits per second, that is also available. So, you see this is how the speed can be increased, and this requires replacement of network interface card. So, whenever you change the technology, you go from Ethernet to fast Ethernet or fast Ethernet to gigabit Ethernet, there is a need for changing the network interface card. However, there is a and switch is nothing but a fast bridge. We have already discussed about the function of a bridge. Although it functions as a physical star, I mean it functions not only as a physical star, but also as a logical star. Why? Because if you connect a computer here and also connect another computer here, and suppose you connect another computer here, so 3 computers or 4 computers, let us assume, are connected there. Now, since it is a fast bridge, as we know, this particular computer, this A, can communicate with B and C can communicate with D simultaneously, because each port has a buffer and each port has separate, and also each port has separate collision domain. That means the signal present here need not be present all other ports. The signal present here is only transmitted to the destination port, to the computer where the destination station is connected, and because of that each port has got separate collision domain. So, collision domain here is separate. Earlier it was having, the entire ring was having the same collision domain. Here the collision domains are restricted to each of these ports, and also each port has a dedicated bandwidth. That means if it is a 8-bit port, essentially the bandwidth is 80 megabits per second. And another advantage of this switch approach is that whenever it is a hub, we cannot have full duplex communication, and here you can have full duplex communications. Suppose A and B are having 2 pairs of wires, then it can transmit as well as it can receive. So, both can transmit and receive simultaneously. So, full duplex communication is possible whenever you are using this switching technology. Moreover, there is no need for CSMA CD. The reason for that is, since there is no shared medium, there is no need for collision, there is no possibility of collision, and as a consequence there is no need for CSMA CD protocol for collision detection and get out of collision. So, here since they can be communicate simultaneously among themselves, the CSMA CD function may not be needed. And we know that in case of a switch, there are ports are provided with buffer, then switch maintains a directory address number and port number, as you already know. So, based on the destination address, a packet is forwarded to a particular port. Now, each frame is forwarded after examining the address number and forwarded to the proper port number. There are three possibilities exist in this particular case. The three possibilities are, in the first case, it can be cut through. By cut through, we mean that suppose this is the frame. As we know, there are starting delimiter and various other things. Then you have got a destination, a source address and destination address. Now, as soon as the destination address is available, immediately it can be forwarded to the port without looking at the remaining part of the frame. So, this is known as cut through approach of forwarding. And however, whenever a frame is forwarded in this manner, we cannot say that the frame is free from collision or from error. The reason for that is, as you know, for detecting collision, it is necessary that the frame must be of 64 bytes, but 64 bytes will be somewhere here. So, unless you receive 64 bytes, you cannot give guarantee that the frame will not suffer any collision. That means, you are sending a frame, forwarding a frame before receiving 64 bytes, and as a result collision may not be detected. So, you may be sending a frame which will suffer collision. And also, as you know, that that frame check sequence is present somewhere here near the end. So, unless you receive the entire frame up to that part, you cannot really detect collision, you cannot detect error. So, whenever you receive up to 64 bytes, then send it, you can say that it is collision free. So, but in this case the frames are forwarded with error detection, but because you are not waiting till the end of the frame. And however, when you receive the entire frame, buffer it, detects error, then if you find that it is error free, only then forwards it, then it is called fully buffered. So, you see, depending on the three basic approaches, it can be cut through, collision free and fully buffered. Obviously, here the delay is minimum, and in this case the delay is maximum. The reason is that you have to receive the entire frame, perform the error checking, then you can send it. And this collision free has got some intermediate delay between minimum and maximum. In this case, you have to receive up to 64 bytes, then forward it. So, these approaches are being used in case of switches, whenever you are using this switching technique. Now, let us focus to the other approach. As I said, that the speed can be increased by increasing the speed of the data transfer rate. So, from 10 megabits per second, it can be extended to, it can be increased, enhanced to say 100 megabits per second. So, this is your fast Ethernet. However, when the IEEE convened a meeting of the IEEE 802 committee to increase the speed of the Ethernet, there were two distinct proposals. Many people were not happy with the Ethernet because of the probabilistic nature of the transfer. As you know, there can be unbounded delay, there can be, and it is possible that a frame cannot be forwarded, it cannot be transmitted. A particular frame may suffer many collisions, as a result it may not be sent to the destination. So, to overcome these problems, one group suggested that redo everything. However, another group said that increase the speed, keeping everything same, and this led to the standard IEEE 802.3u. This is essentially the fast Ethernet, and it was proposed sometime in June 1995. But another group suggested that you simply discard that Ethernet scheme and propose a fully new standard, which was known as 802.12, which is essentially 100 VG NLN. Data transfer rate is again 100 megabits per second. However, it uses a completely different approach. Unfortunately, this particular standard has not become popular, so I shall not discuss it in this particular lecture. And on the other hand, the fast Ethernet has become popular because of the widespread deployment of Ethernet. Let us look at the features of fast Ethernet. The IEEE 802.3u that is the standard used for fast Ethernet, and it was not to be considered as a new standard, but an addendum to IEEE 802.3. That means people considered it as an extension of IEEE 802.3, but not a new standard. That means the frame format has been kept same, the length, minimum length and maximum length which is used in Ethernet has been kept same. So, it preserves the backward compatibility. So, since it preserves the backward compatibility and the Ethernet is already time tested, Ethernet is time tested by that time. So, there is no unforeseen problem. All the problems have been already sorted out. So, it uses the same technology at 802.3. However, some new features were added. One of them is auto negotiation. That means network interface cards were provided with some additional functionalities. One is auto negotiation, so that it is backward compatible with Ethernet. That means with the help of this auto negotiation, one can decide whether it will operate at 10 megabits or at 100 megabits. That means a particular network interface card can support both 10 as well as 100 megabits. That means a switch, a fast Ethernet switch can communicate with a computer which can operate at 10, and this can be operating at 100. So, you can see this kind of incompatibility is overcome by using this auto negotiation. So, and also it is provided with multiple capabilities. It can transfer data at 10 megabits per second, and also it can transfer at the rate of 100 megabits per second. However, some changes are being made. Obviously, the physical layer becomes little complicated. So, it added one additional sublayer known as reconciliation layer, reconciliation sublayer, which essentially receives the data from upper layers and then transfers it to the medium independent interface in terms of 4 bits, and then the medium independent interface does the encoding and decoding that we shall discuss. Then it has got a physical layer entity, which is essentially that that medium independent layer that is being used in Ethernet. Then of course, you have got medium dependent interface, which is essentially depends on the medium that is being used, and here are the different mediums that is being supported by the fast Ethernet. So, it can use Cat3 unshielded twisted pair, it can use Cat5 unshielded twisted pair, and also it can use multimode fiber, and also multimode fiber. And so far as the topology is concerned, it supports only hub or switch. That means it does not support the bus technology which is used in Ethernet. So, it is essentially hub or switch based. So, a hub or switch can have multiple ports, as we have already discussed, and essentially it uses the star type of topology. It does not support the bus topology. Then it uses CSMA/CD protocol. However, as we know, there is a need for minimum size of the frame, or you have to reduce the length of the delay of the network, reduce the size of the network, so that the collision detection is ensured. And as we know that 64 bytes is used in case of Ethernet as the minimum frame size. So, since it has retained the same size, it had to reduce the number of repeaters, so that within that 64 bytes, using 64 bytes collision detection can be done only if 2 repeaters are being used in fast Ethernet. 5 repeaters which are used in Ethernet cannot be used in case of fast Ethernet. So, here as you can see various implementations of fast Ethernet. So, there are 2 versions, one is 2-wire and another is 4-wire. So, 2-wire version is mentioned as X, 100 base X, that means entire transmission is baseband, the data transfer rate is 100 megabits per second, and you have got that X stands for two-wire communication. On the other hand, there is 100 base T4, which is four-wire communication. Let us see the four cases. So, first we shall consider the 100 base TX. This is your 100 base TX, where that 4B by 5B block encoding is used. As you can see, that reconciliation layer is supporting 4 bits, is supplying 4 bits at the rate of 25 megabits per second. It is receiving it and converting into 125 megabits per second. This is the baud rate generated by the block encoder, and then it is performing MLT3 line encoder. MLT3 line encoder is essentially multi-line transmission using 3 levels. So, it uses +1, 0 and -1 levels, and it is very similar to inversion encoding. However, the whenever a 1 is encountered in the beginning of 1, it changes from say +1 to 0, then or 0 to -1, and like that. So, it is very similar to that inversion encoding. However, there are 3 levels being used here in case of MLT3 line encoder, and this signal is being sent in case of this 100 base TX, and as you have seen, 100 base TX uses category 5 unshielded twisted pair, and which can give a maximum length of 100 meters. On the other hand, the 100 base FX, where optical fiber is being used, that NRZ inverse line encoding is used. The block encoding is same, 4 bit by 5 bit encoding is being used. So, the baud rate is 125 megabits per second. You may be asking why Manchester encoding has not been used. Instead of that, 4 bit by 5 bit block encoding has been used. The reason for that is that if Manchester encoding is used, the baud rate will be 200 megabits per second. So, the cost of implementation will be very high. So, to reduce the cost of implementation and to have lesser bandwidth, this encoding is being done. However, by using this encoding, it is possible to recover the clock. That means clock synchronization is achieved. There is enough number of transitions in the signal. And in case of fiber optic medium, instead of using MLT3 encoding, NRZ line encoding is used as it is shown here. So, it has got 2 levels. Then when you are using 4-wire, there are many installations where category 5 is not present. So, Cat3 cable is already present. So, if you want to utilize the existing cables, then you can go for this 100 base T4, and here as you can see that 100 megabits per second signal is converted, that each 8 bit is converted into 6 bit. So, that is 8 bit by 6 bit encoding is being used, and this is being sent. You will require 4 pairs of wires. However, to reduce the cost of implementation, it uses 4 pairs of wire, and as you can see that one port of 25 megabits, 2 25 megabit ports, one is exclusively send or transmit, another is exclusively receive, and 2 ports are bidirectional, send and receive. So, these 2 are used for collision detection and purposes. On the other hand, here you can use both transmit and receive. So, by using 4 pairs, you can transmit at the rate of 100 megabits per second, and you can use category 3 cable. So, these are the 3 different types of physical media that is being supported by 80 by Fast Ethernet. Now, in 1995, Ethernet captured 86% of the local market. So, total market. That means Fast Ethernet became very popular, and as a result, there was need for enhancing this technology. You may be asking why this Ethernet became so popular. So, first the Ethernet was proposed, then Fast Ethernet was proposed. Both were compatible, they can be used simultaneously. and the reason for their success is higher reliability, availability of management and troubleshooting tools. It is highly scalable, you can very easily expand the network, cost of implementation gradually reduced, and switch cost per port reduced continuously with time. That means because of the widespread deployment, the cost of implementation became very small in case of Ethernet, and as a result FDDI and ATM, which were used in the intermediate period, gradually were phased out and which were taken over by fast Ethernet technology. So, this FDDI and ATM, which can be considered as second generation high speed local area networks, were gradually replaced by Ethernet. However, 100 megabits per second were not found to be adequate. So, a new standard was developed, which is essentially known as gigabit Ethernet. So, this gigabit Ethernet, the key objectives were a higher speed network at the backbone level, which can support data rate of 100,000 megabits per second. So, frame format to keep it to retain backward compatibility, again the frame format were kept same, minimum and maximum frame sizes, and also it allows both half duplex as well as full duplex operation. Normally full duplex operation is used, however, to maintain compatibility, backward compatibility, half duplex is also supported. So, it uses CSMA/CD with at least one repeater with collision domain diameter of 200 meter. So, you see in case of Ethernet the number of repeaters were 5, in fast Ethernet it was reduced to 2, and in case of Ethernet it was in case of gigabit Ethernet it has been reduced to only 1, so that the collision detection is possible. And it uses only starred wire topology, that means no bus topology is supported here. It is based on again hub or switch, and multiple ports are provided on this hub or switch. And also it supports fiber as well as copper, at least 25 meter on copper and at least 500 meter on multimode fiber, and at least 2 kilometer on single mode fiber. And also it has added some more features which were not present in Ethernet or fast Ethernet, that is flow control. I shall discuss about it a little later. So, these are the functional elements of gigabit Ethernet technology. So, as you can see, the physical layer has got several alternatives, several layers: media access control, MAC layer, full duplex or half duplex as I have mentioned. Then it has got gigabit media independent layer. Then there are other functionalities which are performed. It uses 8-bit by 10-bit encode decode whenever it is that X transmission, 2-way transmission. On the other hand, whenever it uses 4-way transmission, then it is 1000 base T, and encoding decoding is different. I shall discuss about it in detail, the various types of mediums used. As you can see, in 1000 base LX it uses long wave optical fiber, and in 1000 base SX it uses short wave optical fiber, and 1000 base CX it uses shielded balanced copper, 120 ohm balanced copper, and in 1000 base T it uses UTP, category 5 UTP. So, it supports 4 different transmission medium, and the standards are referred to as 802.3Z physical layer for these cases, and in case of this 1000 base T it is referred to as 802.3V physical layer. Now, to provide more flexibility, one important functionality which is known as gigabit Ethernet interface carrier has been introduced by the developers of gigabit Ethernet, and this GBIC, gigabit Ethernet interface carrier, allows network managers to configure each port on a port by port basis. That means you can use 1000 base CX on one port, 1000 base T on another port, 1000 base SX on another port, 1000 base LX on another port. So, and supporting different types of lens using different types of optical fiber and laser. As you can see that 1000 base SX uses 780 nanometer laser and 1000 base LX uses 1300 nanometer laser. In addition to that, there is some value addition. This value addition is done by providing another standard, that is another medium, that is long haul LH medium, that supports a distance up to 5 to 10 kilometer by using single mode fiber. So, you see, even by sending data at the rate of 10 megabits per second, you can send up to a distance, you can send up to 5 to 10 kilometers. So, this is definitely a very big advantage of gigabit Ethernet network. Now, let us look at the encoding techniques that is being used in gigabit Ethernet. So, you can see here this 1000 base X, as I was telling, which uses two wire networking, either copper or optical fiber. So, it receives 8 bit from that reconciliation layer, then it performs 8 bit to 10 bit block encoding, so that synchronization is possible. So, the here that the data that you get is 12.5 gigabits per second. So, there is something wrong here, there will be a decimal point, 12.5 gigabits per second. This is the baud rate, and it uses energent line encoding to send data on the optical fiber or copper, whatever it may be. On the other hand, when this 4-wire cabling is being used, that uses category 5 cable, as you have seen, that uses category 5 Cat 5 UTP. In that particular case, a very complicated encoding technique is used. That technique is known as 4D, 4-dimensional 5 levels pulse amplitude modulation. 4-dimensional 5 levels pulse amplitude modulation. That means it receives the 8 bits from the reconciliation layer at the rate of 125 megabits per second. Then this encoding, this complicated encoding is done to transmit data on 4 wires, and it can support up to 25 meter. So, up to 25 meter this 4-wire cabling can be done for short distances. Otherwise, one can use that shielded twisted pair, which can also use 25 meter, that is 10,000 base CX, or you can use a copper optical fiber to support up to 100 meter or 500 meter or 3 kilometer, or it can be 5 to 10 kilometer. Now, these are the key features of gigabit Ethernet. It is not simply Ethernet running on 1000 megabits per second. So, what you can say, it is not just the extension of speed, it has added many more features. First of all, it has to do carrier extension, as I mentioned, that although it uses 64 bytes of minimum packet size, that is not enough for detecting collision when you are transmitting at the rate of 10 gigabits per second. In such a case, you have to use 500 bytes. However, the frame can be of 64 bytes and carrier is extended to 512 bytes to achieve 200 meter collision domain, keeping the frame size same as minimum frame size as 64 bytes. And also another feature has been added, which is known as frame bursting. After the slot time, it can continue to send it allows additional frame transmission, because it is sending at a fast rate. Once a token has been grabbed, once it is sending, and instead of sending just one frame at a time, it can keep on sending multiple frames after the slot time is over. Then it can use buffer distribution. All incoming frames are buffered in first out order. That is another feature added. And also it does flow control using X on X off protocol, which is not present in gigabit fast Ethernet or Ethernet. Since it is using full duplex communication, this X on X off protocol can be supported, which I shall explain. For example, this is that X on X off protocol. So, this is the switch and this is the server. Suppose the server is sending at a very high speed, high speed. So, data is going to the switch, and then unfortunately the switch is not able to transfer data. That means it is buffering the packets, but the other stations which are connected to it are not able to receive at that rate. So, switch is getting congested. So, it will send a pause frame. So, in the reverse direction it will send a pause frame, and after receiving that pause frame, the server will end session and wait required amount of time before sending. It is somewhat like stop and wait protocol. Stop and wait protocol that is being used for flow control. So, same is being implemented by using this full duplex line, and which is known as X on X off protocol. Moreover, in Ethernet and fast Ethernet there is no quality of service. The reason for that is, that because of the CS-MACD protocol, it is probabilistic, there can be unbounded delay, there can be loss of frame, which cannot be accepted in many applications, particularly in real-time applications. So, a quality of service has been added to this standard in case of gigabit Ethernet to support consistent bandwidth and jitter, and the standards are named as 802.1p and 802.1q. By following these standards, the quality of service is maintained by gigabit Ethernet, so that gigabit Ethernet can support real-time traffic like voice and video, which cannot be supported by Ethernet. So, now it is you can say that what are the typical applications of gigabit Ethernet. So, these are the areas where gigabit Ethernet can be used. You can upgrade switch to switch links. For example, you have got two switches which are fast Ethernet switches. These two can be linked with the help of a gigabit Ethernet switch, and these are known as uplink ports. With the help of these uplink ports, which are provided as one gigabit Ethernet port, you can do these kind of links as shown here. Then upgrading switch to server links, say server which can transmit at a high rate, you can have gigabit Ethernet network interface card and then link it to a gigabit port of the switch, and this is where gigabit Ethernet can be used. And upgrading the switched fast Ethernet backbone. Suppose this switch was earlier a fast Ethernet switch, it can be replaced by a gigabit Ethernet switch which will form as a backbone network. And you can upgrade a shared FDDI backbone. As I said, FDDI is more or less a outdated concept now, not being used in practice. So, this can be replaced by gigabit Ethernet switches. So, these are the typical applications where gigabit Ethernet can be used and migrated in the fast Ethernet network or FDDI network. So, now it is time to give you the review questions. First question is how FDDI offers higher reliability than token ring protocol. Second question is distinguish between a switch and a hub. Third question is why 4B by 5B encoding is used in fast Ethernet instead of Manchester encoding. Fourth question is what is carrier extension, why is it used in gigabit Ethernet. Fifth question is how flow control is performed in gigabit Ethernet network. So, here are the answers to the questions of lecture number 28. First question was list the functions performed by the physical layer of 802.3 standard. Answer is functions of the physical layer are data encoding decoding to facilitate synchronization and efficient transfer of signal through the medium, collision detection, carrier sensing, and it also decides the topology and medium to be used. So, this is the function of the physical layer. Second question was why do you require a limit on the minimum size of Ethernet frame? As I mentioned, to detect collision it is essential that a sender continue sending a frame at the same time receives another frame sent by another section. That is how collision is detected. So, considering maximum delay with 5 Ethernet segments in cascade, the size of frame has been found to be 64 bytes such that the above condition is satisfied. third question was why token bus is preferred over CSMA-CD. The answer is CSMA-CD is a probabilistic protocol. A station which wants to send data may get access after an unbounded time. Because of multiple collisions, a station may take enormously long time to access the media. If a station is unfortunate, it may not get access at all to send data, which is not acceptable in factory automation. So CSMA-CD does not allow priority, but priority is needed for station of ordinary to send, so that ordinary data and real timing data can be transmitted. So lack of priority scheme is the drawback of CSMA-CD protocol. So to overcome these drawbacks, token bus protocol is preferred over CSMA-CD protocol, but not always. Then here is the answer to question number 4. What are the drawbacks of token ring topology? Answer is token ring protocol cannot work if a link or a station fails. As you know, there is no built-in reliability provided in token ring. On the other hand, so it is vulnerable to link and station failures. This is being overcome in FDDI. So how the reliability of token ring topology can be improved? So reliability of ring topology can be improved by implementing the ring topology using varying concentrator, as you have seen, and this allows not only to detect fault but also isolate the faulty link or station with the help of bypass relay, as you have already seen. So here are the answers of the questions given in lecture number 28, and with this we conclude our discussion on high speed local area networks, and in this lecture we have discussed FDDI, fast Ethernet, gigabit Ethernet, and also the concept of switched local area networks. In the next lecture we shall discuss the wireless LAN. Thank you.